been having a lot of conversations with my students about what our priorities are when we are trying to introduce new physics concepts to students. Because I feel like there's this trend among some channels of physics education, not all of us, but there's a trend where if the students aren't understanding it, let's just present it more formally, or let's present it more accurately. And I get that. I get that we want to present an authentic physics learning experience, right? We want to present the material in such a way that the students aren't shocked when they see the full-fledged physics later on. Kind of the extreme example of this is that that graphic of the big equation that has all of physics in it, just kind of thrown into a Lagrangian. And I like that. It's cute. It's nice to know that, yeah, you can cram all of physics together into a couple of lines, and it describes everything we know about the universe. And it's kind of cool. And it's nice to know that that exists. But who's going to teach out of that, right? Are students actually going to learn anything from that, even at the graduate level? And the reason I bring that up is because, yes, we absolutely want to have an authentic learning experience, but we also want to make physics accessible. And I feel like there's this other strand that says, well, no, we need to work on making physics accessible. We need like take IEL, for example, where you only teach the physics that the students discover in lab. I just got done listening to the Physics Alive episode with Natasha Holmes. Wonderful episode. Highly recommend it. But there's kind of that other extreme of, well, we're only going to teach what the students are, what's exactly within their reach right now. And that's useful too. But we also want to work on, expanding that reach. And so the way I've been thinking about it lately is we have accuracy and we have accessibility. And we need both. We absolutely need both. And we can't chase one at the expense of another. And so in physics lingo, these are two orthogonal properties. They're two axes. And I think a lot of the times we perceive these axes as kind of having an opportunity cost curve, where we can either have high accessibility and low accuracy, or we can have high accuracy and low accessibility. And most of us try to waddle around in the middle somewhere. And I think that's kind of a good picture for understanding, what our constraints are in terms of what we're doing with our classes. Like, are we pursuing the accuracy axis at the expense of the accessibility axis, or are we pursuing accessibility to the point where we're not showing them, a full picture of physics? And ultimately, I think what our goal is to do both, and we want to take that opportunity cost curve and expand it. We want to give it a bigger radius so that we can more or less move at a 45-degree angle. I say more or less because, maybe you're teaching a course where you want high accessibility and you're not really worried about the accuracy, right? So like the physics for poets and presidents class. I mean, as long as they're getting the idea that, yes, physics is real and we do know what we're doing with it, and you can trust us when we tell you things like the earth is getting warmer and we are the cause. On the other hand, for our physics majors, well, but even then, I don't think you want to pursue accuracy at the cost of accessibility. I mean, I would tend to always think you want 45 degrees or less. It's a hard sell for me to teach a class that is higher than 45 degrees on that axis there. But at the same time, I feel like the reason I bring this up on a Computational Thursday is that I feel like computation is really one of the best ways you can expand that opportunity cost curve, because computation is incredibly accessible. Once you get past the initial, oh dear, I don't know how to do computer programming, which I find you can do after a few weeks. So in my Physics 2 lab, we're doing a computational modeling activity every other week. And so at this point, we're in week 7, I think, and we've done 3 of them so far. And I gave the third one to my class yesterday, and they just ran with it. They hardly asked any technical questions. They mostly asked, we were doing a magnetic field of current loops, and they had to set up all these cylinders in VPython to represent where the current was going. And we hadn't done a cylinder before, so I just had to explain to them the position attribute and the axis attribute. And they ran with it because they understood the position's a vector of where it starts, the axis is a vector of where it points, and they knew by now copy, paste, modify, and run it and keep modifying it until it does the thing you want. And they learned a lot from it. They came up with some really cool magnetic field patterns there. But I feel like once you kind of get past that initial accessibility barrier, I feel like computation is one of our best tools for expanding the opportunity cost curve so that you can pursue both accuracy and accessibility, because computation makes nearly everything accessible. I mean, anything you want to do within a course, you can do with computation. So like my students were doing, like yesterday, my students were doing a loop of current this way and a loop of current this way. A couple of them made a cube of current going around. I don't know how accurate the current flows were in terms of the, conservation of charge and everything. And so they were, within a few weeks, we were at a pretty nice 45-degree angle, far out position of doing something accurately of a real world, messy system that you can't do analytically that was also accessible. And so I feel like, I don't know, is this a thing that lots of other people think through and talk through, and I'm just kind of late to the game and it's been percolating around subconsciously? Is this a helpful framework for thinking about how we approach our classes and how we structure what our students do? Am I leaving out some dimension? Is there some third word that starts with ACC that I need to include in this model? Or is accuracy and accessibility not the basis we need to be thinking about? Let me know what you think in the comments below. Would love to carry on this conversation.